When current flows through a conductor, it creates a magnetic field. The strength of the magnetic field depends on the amount of current and the distance from the conductor. In the case of a 3-wire non-metallic sheath cable, the magnetic field will be strongest around the cable itself. Now let's consider the effect of feeding and switching a 3-way from the same box. When a 3-way switch is fed and switched from the same box, it creates a loop circuit. This loop circuit effectively cancels out the magnetic fields created by the two switch legs, resulting in a negligible electromagnetic field, also known as EMF. Therefore, there is no significant EMF issue when feeding and switching a 3-way from the same box. Next, let's address the 3-wire non-metallic sheath cable running between 3-ways. This cable does not have a significant EMF because the current flow is balanced in both directions. The magnetic fields created by the current flowing in one direction are cancelled out by the magnetic fields created by the current flowing in the opposite direction. Regarding the area affected by the EMF from a 3-wire non-metallic sheath cable running between 3-ways is negligible. The magnetic field strength decreases rapidly with distance from the cable. Finally, let's discuss the exception for switch loops without a neutral, as mentioned in the National Electrical Code, specifically section 404.2. This exception allows switch loops to be run without a neutral because the current flowing in the switch loop is very small compared to the current flowing in a typical branch circuit. This small current results in a negligible electromagnetic field, making a neutral unnecessary. So, to recap, firstly, current flow creates magnetic fields. Secondly, magnetic field strength depends on current and distance. Thirdly, a 3-way switch fed from the same box creates a loop circuit. Fourthly, this loop circuit cancels out magnetic fields, resulting in negligible EMF. Fifthly, a 3-wire non-metallic sheath cable between 3-ways has balanced current flow. Sixthly, balanced current flow cancels out magnetic fields. Seventhly, the EMF from a 3-wire non-metallic sheath cable between 3-ways affects a negligible area. Eighthly, the National Electrical Code, section 404.2, allows switch loops without a neutral. Ninthly, switch loops have very small current compared to branch circuits. And tenthly, the small current results in negligible EMF, eliminating the need for a neutral. In summary, the configuration of a 3-way switch wired with a 3-wire non-metallic sheath cable, particularly when fed and switched from the same box, results in a minimal electromagnetic field. The balanced current flow in the conductors effectively cancels out the magnetic fields, minimizing the EMF impact. Furthermore, the exception in the National Electrical Code allowing switch loops without a neutral is based on the principle that the current in these loops is so low that the resulting electromagnetic field is negligible. This means that the presence of a neutral wire is not required for safety or functionality in this specific application. The area affected by any residual electromagnetic field is also very small, decreasing rapidly with distance from the cable. The balanced current flow in the 3-wire non-metallic sheath cable contributes to the reduction of the electromagnetic field, as the magnetic fields generated by the current flowing in opposite directions tend to cancel each other out. This cancellation effect is particularly pronounced when the conductors are closely spaced, as they are within a non-metallic sheath cable. Therefore, the overall electromagnetic field produced by this wiring configuration is significantly reduced compared to other circuits with higher current levels or less balanced current flow. The National Electrical Code's allowance for switch loops without a neutral is a practical application of these principles. By recognizing that the electromagnetic field generated by these low-current circuits is negligible, the code permits the use of a simplified wiring configuration that reduces material costs and installation complexity without compromising safety. This exception is not a blanket exemption for all circuits without a neutral, but rather a specific allowance for a well-defined application where the risks associated with electromagnetic fields are minimal. It's important to note that while the electromagnetic field in this scenario is negligible, it still presents to some degree. However, the level of the field is far below the threshold that would be considered harmful or problematic in typical residential or commercial environments. The magnetic fields decrease significantly with distance, reducing any potential interference with other electrical devices. In conclusion, understanding the principles of electromagnetic fields and current flow is essential for safe and efficient electrical wiring practices. The specific configuration of a three-way switch wired with a 3-wire non-metallic sheath cable, when properly installed and maintained, presents a minimal risk of electromagnetic field-related issues. The balanced current flow, the proximity of the conductors, and the low current levels all contribute to reducing the overall field strength. The exception in the National Electrical Code for switch loops without a neutral reflects this understanding, allowing for a simplified wiring configuration without compromising safety.